Now we will go on for DID Oration program. So I would like to invite Dr. Saurabh Srivastava. He is a chairman UPDA GBN chapter. Dr. Amitesh Aggarwal, secretary UPDA GBN chapter, to invite Dr. Sir V Madhu for oration.
Good afternoon. We have started last year DID oration conferred to Dr. Sethu Reddy, who is now President-elect of American College of Clinical Endocrinology. This DID oration is awarded in the recognition and sincere appreciation of the outstanding work and contribution in the field of diabetes. This year, DID oration is being given to Professor Dr. V Madhu, who is Director and Professor of the and Head of the Department of Endocrinology and in charge of Center of Diabetes, Endocrinology and Metabolism. He is also past president of ESI and RSSDI. He is the editor-in-chief of Indian Journal of Endocrinology and Metabolism, and he has published many papers and has done many projects. Now I ask to show the clipping of the oration which was in comfort to Dr. S. V. Madhu. Now I invite Dr. S. V. Madhu sir for his oration.
Thank you. And at the outset, I would like to thank DID for awarding me this oration this year. It's an honor and pleasure to be amongst friends, colleagues, and many of my students to deliver this oration and share some of my recent work. What I'll be doing actually, let me share my screen first. Yeah, so what I'm going to do is over the next 20-25 minutes, talk about this topic, which is emerging. It's a monologue. I mean, let me tell you, in the Dialogues of Diabetes session, it's a monologue, one of the few monologue sessions, and it's not on management, but it covers recent interest, and it also covers an area, East Delhi, from where most of the patients were recruited. So it might interest East Delhi physicians. So that's the reason why I've actually chosen this topic. It's basically organochlorine pesticides and the risk of diabetes among Indians. And recent publications over the last 1.5 years in this regard will be touched upon. Okay. So basically, environmental pollution is a major problem of today's world. We all know that. And it's an accumulation of a substance which is expected to produce harmful effects on human health. And it's basically an interaction of three things: the intrinsic genetic susceptibility, and we'll touch upon this towards the end of the talk; environmental exposure in the form of pollutants, and also on several other factors, including the nutritional status, gender, age, and behavior, all of which interact to cause human disease. And in terms of environmental pollution and diabetes, there has been an increase in prevalence, and most of the increase has been attributed to lifestyle factors, particularly diet and physical activity. And it's only in the last few decades that people have suspected and focused on environmental chemicals as an important factor in the pathogenesis of diabetes. And there are several of these, and among which I'll be focusing today on the persistent organic pollutants, or also the organochlorine pollutants as they're called. Pesticides, as we know, are mixtures of substances intended for preventing, destroying, repelling, or mitigating any pest, and several of these exist, including the HCH, aldrin, dialdrin, DDT, and its metabolites, and so on. The importance in our country is that we host the largest pesticide manufacturing industry in the world, And most commonly we use HCH, aldrin, dialdrin, endosulfan, DDT, etc. And it's been thought that OCPs get concentrated in the fat of the human body, and increase its levels in this adipose tissue is what leads to diabetes in the long run. And what we think as obesity being the predisposing factor to diabetes, some feel is only because of the associated OCP contamination. And if you see this slide, the first one in particular, you find that Indians, compared to the rest of the world, the use of insecticides is far more. And therefore, it's an important problem for us to address. 40% of all pesticides used in India are the organochlorine pesticides, and they possess long half-life, wide persistence in the environment as well as in the adipose tissue for years and decades. And that's why their risk and the potential for endocrine disruption is huge and persistent. Human beings are the top consumers in the food chain, and therefore at the highest risk to the bioaccumulation of OCPs at all strata. They possess several properties, and the most important among the various diseases that they can cause, it will be, apart from cancer, of course, we'll be touching on diabetes. And this is the pesticide cycle, which just tells you how the pesticides persist in the atmosphere for decades in the soil or the water and so on. The OCP residues are above the permissible lipids, and these have been detected in the blood, urine, breast milk, and adipose tissue, suggesting that there is persistence and they can cause different hazards. With that background, what is the link between insulin resistance, dyslipidemia, and glucose intolerance with the OCP? OC pesticides are continuously released from fat stores into the blood, and from there they reach the critical organs where they disturb some biological functions. And in 2006, a South Korean team actually reported that people with diabetes tended to have elevated pollutant concentrations in the blood. Overweight and exposure to POPs may have a synergistic effect on the risk of diabetes, as we'll learn. All the risks of diabetes attributed to obesity, I mentioned this before, many people believe is because of the persistent organic pollutants, and obesity is just a vehicle for such chemicals. And it's believed to have an inhibitory effect on insulin action, and that's another way supposed to cause diabetes risk. Okay, there's been a strong epidemiological link between OCP exposure and obesity and type 2 DM, several studies which are listed on this slide, and several others which, as you can see from this, the odds ratio of diabetes with various organopollutants goes on increasing and is in the range of 2 to 3 or 4. And depending on the studies, you may have different risk scores. Here again, we've found that in this study, Lee showed, this is a prospective study, where they showed that in 20 years of follow-up, again, there was an important risk association between PPDDE, one of the metabolites of DDT, triglycerides, BMI, HOMA-IR, and so on. And two other prospective studies which actually evaluated POP mixtures, not individual pesticides, but mixtures of pesticides, and showed again a 3 to 5 times less. So there is a huge epidemiological link. And these could be the various mechanisms. People have thought that there is inflammation in the adipose tissue, which is caused by the OCPs, and also contributed to insulin action. And several aspects of insulin action, including lipogenesis, have been thought to be the culprits. And certain other receptors, including the PPARs, gammas, are also thought to be the mediators. But what is more important is, what about our population, and do we really find all these in our population as well? From our center, I think I was not involved in this particular study, but our group, one of the groups from our center actually found in the metabolic syndrome that beta HCH in particular was found to be significantly higher in those patients with metabolic syndrome compared to controls. And from there, we took on this topic, and because of the emerging interest, we thought we should investigate its link with glucose intolerance. And this is a recent publication in January 2021 in a high-impact journal of as high as more than 6, where we actually showed that the level of organochlorine pesticides in pre-diabetic as well as newly detected diabetic patients was high, and insulin resistance, particularly in the group of populations coming to our hospital, and their attendants and all those whom we could screen. The study was actually conducted in 300 patients, 100 NGTs, 100 pre-diabetes, 100 newly detected diabetes based on the oral glucose tolerance test. And we looked at these levels in all of them. What did we find? As you can see from this chart, basically, several of these organochlorine pesticides, particularly you could focus on the second, the beta HCH. You could also focus on the aldrin, the dialdrin, and the PPDD, all of which shows a graded increase in levels going from control to the pre-diabetic to the diabetic. And if you look at the significance, actually most diabetics as compared to controls, and many times even the pre-diabetics compared to controls were significantly higher, suggesting that there could be a link between the OCP levels and diabetes and pre-diabetes as well. And if you look at multiple regression models, actually you found that the risk of diabetes, once you adjusted for age and body mass index, that is model 2, was anywhere from 2.7, 2.8, or 2.5 times odds ratios. And if you look at it a little more and divide it according to the BMI, in those above 25 kilogram per square meter, the risk was much higher, 10 times with beta HCH, 7 times with dialdrin, and over 10 times with PPDDE, again DDT. So suggesting that there is a clear link, although these studies are cross-sectional, there are clear link between OCP levels in the blood and risk of diabetes mellitus. So we concluded that there are high levels of these agents in these populations with high odds ratios of risk of diabetes, and insulin resistance showed positive significant correlation with several OCPs. Fasting and PP glucose also significantly correlated, and hence OCP levels in the blood may increase the risk of developing newly detected diabetes mellitus in North Indians and could be crucial in an etiologic role, although this was still a cross-sectional study. Taking it a step further, and this is the second study, again recently published this year in 2021 in an even higher impact journal, which is about 8. High levels of organochlorine pesticides in drinking water. And this is where the East Delhi physicians should be interested, because the drinking water is the water supply mostly supplying East Delhi. And what did we find in this study? Firstly, we found that the groundwater, luckily most of us probably are not using groundwater. Whether it is tap, filter, or groundwater, the levels were high, but it's only in the groundwater samples that the levels were higher than permissible limits. The others, although were showing some high tendency, as you can see even on the slide, they were within permissible acceptable limits, but the groundwater was certainly very high in OCP concentrations. And when we compared the groundwater levels with the risk of prediabetes and type 2 DM, as you can see very clearly, the PPDDE in particular and the OPDT, both of which are metabolites of DDT, which metabolites could occur even outside the body. And these correlate these significantly increase as you go from controls to pre-diabetics to newly detected diabetes, and therefore suggesting that there is a link between the water OCP concentrations, which could be taken in any form, and the risk of type 2 diabetes. OCP levels in the blood was also studied in this, and it just confirmed what we had shown in the earlier study. Now, this is more important. Among those who were consuming groundwater, as you can see, only 20% had normal glucose tolerance. And nearly 40%, or approximately 40% each, had pre-diabetes or diabetes. And therefore, consuming groundwater, particularly in East Delhi, is fraught with risk in terms of type 2 diabetes. Now, further doing a component analysis, again, we would see if you put all the OCPs together, there is a 13.36% contribution to the risk of diabetes just through different OCPs. You add TGs and it becomes 21. So there's a further increase in 9% or so, or 8%. And then you add LDL, it becomes 29. That's another 8%. Add BMI, it becomes another 7%. And finally, all the common risk factors put together account for 41% of the risk, of which 13% is actually by the OCPs. And the conclusions were quite clear that high levels of various OCPs found in groundwater samples correlated with prediabetes and type 2 diabetes mellitus, and recruited subjects consuming contaminated groundwater actually posed a serious problem in that 40% had diabetes and 40% had prediabetes. And consumption of groundwater, therefore, probably triggers many factors that promotes the risk of diabetes. These need to be worked upon in more longitudinal studies and probably larger studies to see the impact of such contamination. Then coming to the second aspect of what we did, what is the link between POPs and lipids? POPs include various lipophilic compounds. Most of these are lipophilic, and therefore there's some link with lipids. They accumulate mainly in lipid-containing tissues like the adipose tissue and move within the body bound to lipids. The persistence is due to their characteristics of high lipophilicity, bioaccumulation, long half-life, and potential for long-range transport. And even though they were banned, several of them were banned earlier, still we find them in considerable amounts in environment as well as the human body. In fact, a workshop concluded that it could be that the risk of these exposures are due to the alterations in differentiation of adipocytes. And it also was suggested that the effects might actually be a combination of the OCPs along with factors such as consumption of high calorie, high carbohydrate, or high fat diet later in life, which is all that we do these days. So if they're present silently in the body, that's one thing. But if you also consume high calorie, high carbohydrate, and high fat diets, the two together probably are a deadly combination, as we'll see in the subsequent slides. In fact, these are two animal studies which clearly showed that dietary fat interacts with the OCPs to cause glucose intolerance. And therefore, we focused on a concept. Is it that if you consume higher fat, because of higher postprandial triglyceride levels, which we've documented earlier in several of our studies, you have greater retention of these OCPs or greater concentration of the OCPs, which are free to get into different organs and cause toxicity. As we see, DDT is the most common type of OCP and is found in the environment as well as its metabolites. And the cardiometabolic risk or consequences of DDT may be greater in those with high PPTG levels. And this may result in greater accumulation of DDT and its metabolites, both in the adipose tissue and other ectopic sites. And as was shown, and as was also alluded to by others, the OCPs being lipophilic actually are absorbed from the gut through the chylomicrons and actually bypass the liver and straightaway go to the systemic circulation in adipose tissue. And levels are found to increase following IV administration proportionate to rise in postprandial chylomicron levels after consuming a high-fat meal in rats. What the last sentence is very small, written very small, but the implication is huge. If you give IV OCPs to a patient or a rat consuming high-fat meal, they have higher levels of PPDD, which is proportionate to the postprandial rise in chylomicron levels, suggesting that there is a close link between the two pharmacokinetically. And this was the basis of our hypothesis. And in earlier studies, we actually have shown that PPTG or postprandial triglycerides have a higher risk for type 2 diabetes, which very few people have focused on. Most of the time, we listen to postprandial TGs as a cardiovascular risk factor, but several studies which are listed on this slide, we showed an association. Finally, conclusively through experimental studies proved that PPHTG is an important risk factor for development of type 2 diabetes. And that being the case, it is possible that some of the risk attributable to the PPHTG or the postprandial triglycerides is actually due to its facilitation of harmful metabolic effects of lipophilic OCPs such as DDT. So that was the hypothesis, and this is a study which ensured where the effect of postprandial triglycerides on DDT and PPDD levels in subjects with varying degrees of glucose intolerance were studied, again published in a 4+ impact factor journal, European Journal of Pharmaceutical Sciences, where we hypothesized that a combination of postprandial hypertriglyceridemia and DDT probably is instrumental in increased diabetes and cardiovascular risk. See, some of the cardiometabolic effects of postprandial hypertriglyceridemia may be attributable to the potential to increase the blood levels of lipophilic OCPs, and we studied OCP levels in patients with NGD, prediabetes, and diabetes again, and looked at the effect of a high-fat meal on the blood levels of OCPs and the relation with the postprandial triglyceride levels, which get elevated by this high-fat meal challenge. So this was the flow. You did serum triglycerides at 0, 2, 4, 6, and 8 hours after a standardized fatty meal. Plasma OCP levels were also measured at the fasting peak and at 8 hours of the TG peak. The PP, and OCP levels were compared in the 3 groups. An association of these with glucose intolerance determined. What did we find? As expected in earlier studies also, we have demonstrated that following a fat meal, you have a progressively increasing postprandial triglyceride levels from NGT to pre-diabetes to NDDM. This is just a confirmation of that. But this is the more important slide. If you focus on this, and this, whether it is the triglyceride AUC or the incremental, where is that? Or the whether it is the triglyceride AUC or the peak TG AUC, these are significantly different between the diabetics and controls, and also the pre-diabetics and the diabetic patients. Similar things were observed with the OCP, particularly the PPDDE, significantly different between the diabetics controls, diabetics and pre-diabetics, and also the peak. So whether it's the OCP peak or the TG peak, they seem to be running parallel in terms of the differences between the NDDM and controls, pre-diabetes and diabetes. Number one. If you do the correlation analysis, there was a very good correlation between the PPTG parameters and PPDDE, suggesting that they run in parallel. And you look at the incremental curves, there the R value is more than 0.5, 0.57, 0.51, suggesting that there's a very, very close relationship between the rise in the postprandial TG peak and the rise in the OCP level or the PPDDE. So what we were hypothesizing, probably at least to these acute studies, very clearly demonstrate that there is an increase, and this also correlates with the glycemic parameters. So what did we conclude? That we found high levels of PPTG as well as PPDD in subjects with newly detected type 2 diabetic mellitus when it was compared with either pre-diabetes or controls, number one. A significant association of PPTG and the PPDD levels with each other and measures of glycemia and insulin resistance, suggesting that the two together are related to or associated with insulin resistance, and of course are related to each other very strongly. And therefore, from these findings, the conclusion obviously is one of two. Cardiometabolic risk factors associated with PPHTG may at least in part be related to the associated increase in serum levels of lipophilic OCPs. Alternately, or even this could be operating, higher risk of type 2 DM secondary to OCP exposure may also be enhanced in the presence of high PPTG levels. So that was the conclusion of that study, and showing very clearly that the two are closely interlinked. So what you consume in terms of diet interacts also with the environmental toxins. The two other studies, which I'm going to finish in the next 3-4 minutes, is about the adipose tissue levels. Here we took it a step further and looked at the adipose tissue levels of DDT and its derivatives as a risk factor. This is what we did. We studied in the adipose tissue, particularly the visible adipose tissue, and tried to correlate in 50 patients with different BMIs and obese and non-obese, and looked at the correlations. And what did we find? Very clearly, in all obese patients, as against the non-obese patients, even if they were non-diabetic, there was a good correlation between the PPDDT and glycemic parameters. And the overall conclusions from this study actually were that type 2 DM and obese patients had higher adipose tissue levels of DDT and metabolites, confirming our hypothesis that it's the adipose tissue accumulation of OCPs, which is an important contributor or important risk factor in the pathogenesis. So excess adipose tissue deposition of PPDDT and OPDDT, etc., in obese subjects may predispose them to type 2 DM by disrupting triglyceride and glycemic parameters, because there's a correlation to some extent with triglycerides as well. Now, the last part of this talk is, what about genetic susceptibility? I mentioned in the beginning, there is an interaction. As you can see from this slide, there are several ways in which the genotype of a person interacts with environmental factors to cause disease. And I won't go into the details, but it could interact at various levels. And in terms of environmental exposure, these are the various steps for causing environmental toxicity, and genetic variability also can be at any level. And therefore, there is a huge gene-environment interaction in this risk, which is what we try to look at. Are there any interactions between OCPs, especially adipose tissue OCP levels, and endoplasmic reticulum stress genes? And as we can see from here, very clearly in terms of these three ER stress genes are upregulated following HCH and endrin, as you can see in the left and the right panels very clearly, this, and this, which are significant. And therefore, there is an existence and simultaneous and continued interplay of genetics with OCPs. And this particular paper is still under review for publication in environmental and toxicology and pollution, and we've submitted it for publication. So basically what I've done in the last 25 minutes is given you not a snapshot, but a series of investigations, particularly from East Delhi, where we try to look at the blood levels of patients, the water levels, OCP levels in the water that they consume, especially the groundwater, and also look at the adipocytes of some of the patients who are undergoing surgery to try and knit the story that environmental pollution, particularly OCP level, correlates or is as an important factor in the pathogenesis of type 2 diabetes, amongst many others which we already recognize. So it is time we wake up to this particular risk factor and are aware that this could also cause disease. And this calls for longitudinal studies, particularly from areas in East Delhi, which we have documented, to show actually that in the long run, also OCPs matter. Thank you. Thank you.
Thank you, sir, for a wonderful deliberation of the about the role of pesticides in diabetes mellitus. And it was really eye-opening for the population of East Delhi as well as the other population also living in villages, that the pesticides can also be a precursor for diabetes. Thank you, sir, for a wonderful oration. Over to Amitesh.
So as always, it was a pleasure listening to you, and we are happy and we are honored that you have accepted the oration and delivered the oration today. So
Thank you.
I thank you from all the participants and the faculty. Thank you so much.
You're welcome.
Thank you, sir.
You're welcome.